Let's have an idea about a quadratic expression. An expression whose degree is 2 is said to be a quadratic expression. And when we represent it as a function, it's called a quadratic function. So most simplified form of the quadratic function is its parent form. In the parent form, its vertex lies at the origin and the graph opens upwards. But most of the times, you see certain added or subtracted terms to this parent form. So we may have to discuss some other forms like a standard form, vertex form, and intercept forms, etc. So let's have an idea about the characteristics of the standard form. The standard form of the quadratic function is given by y equals ax squared plus bx plus c, where a is the leading coefficient. Now there are two cases. A can either be positive or it can be negative. When the A is positive, the graph opens in the upward direction like this. It's a U-shaped diagram. But when the A is negative, the graph opens in the downward direction, just like the inverted U. That's the first thing. Now the second thing is the axis of symmetry. Axis of symmetry is a vertical line that divides the graph into two equal halves. So any vertical line is given by an equation which is x is equal to something. So that something can be figured out using a formula that is x equals negative b over 2a. Once we get the value of x, that is the axis of symmetry, we can also figure out the vertex. We simply substitute the value of x into the given function. We get the corresponding value of y. So together, x and y as an ordered pair forms the vertex. After getting vertex, we have another component over here, that is c. C is said to be the y-intercept of the parabola. So whatever is the value of c, at the same place, the graph intersects the y-axis. After getting that much information, we may need to have few more points. So we simply assume certain values of x, we put them into the function, and we get the corresponding values of y. And after getting the sufficient number of points, we connect them using a smooth curve, and that will be the graph of the quadratic function. Let's take an example. Um, this is the equation that we need to plot. So, so the very first thing we do here is we compare it with the standard form, which is ax squared plus bx plus c. So value of a we have is 2, value of b is negative 4, and the c is negative 1. So the first thing you notice is the leading coefficient. It's positive 2. So we have an idea that the graph will definitely be opened in the upward direction. We don't know how it looks like, but at least we have an idea that yeah, it's a U-shaped diagram, not the inverted one. Now the second thing we must consider is the axis of symmetry. Axis of symmetry is a line that divides the graph into two equal halves. The equation is given by x equals negative b over 2a. Let's substitute the values. B is negative 4, a is positive 2. We simplify this, we get 1. It means that x is equal to 1 is the axis of symmetry. So we can even plot it right away. We can open the graph sheet, and this is my x-axis, that's the y-axis. So the axis of symmetry we got is x equals 1. It means it will intersect the x-axis at 1. So this is the axis of symmetry that we wanted. Okay, so one thing is definite. The turning point of the parabola is located at the axis of symmetry, no matter how it looks like, just because it's the axis of symmetry. So definitely the graph turns from this particular line only. So once we substitute the value of x into the given function, we'll be able to get even the value of y, that will be the vertex. So let us substitute the value of x into the given function. Function is given as y equals 2x squared negative 4x negative 1. That's the equation, and we need to put the value of x as 1. Okay, let us substitute x equals 1. So it's 2 times 1 is squared negative 4 times 1 negative 1. We simplify this, we get negative 3. So at x equals 1, y is negative 3. We can form an ordered pair then. X comma y is actually 1 comma negative 3. Means the turning point or the vertex of the given quadratic function is 1 comma negative 3. We can plot that also. So 1 comma negative 3 is located somewhere here. Okay. Now the other thing we had was the y-intercept. You can notice that y-intercept is negative 1. The value of c is negative 1. So we can plot the y-intercept at negative 1. Okay, so negative 1 is somewhere here. So by symmetricity, we can have its image in the opposite direction here. So we may have to get few more points here. So what we do then, we can simply draw a table, and here we can assume certain values of x, and then we may get the corresponding values of y. I think 1 or 2 points must be sufficient. I think just one value because we have enough point. When we get one value, 1 point here, then other point will be the symmetrical point. So that will be sufficient. 5 points are sufficient for the graph. So we already have, see, we have 0, 1, 2, let's say 3. We put x as 3, and we need to get the value of y. So at x equals 3, we have the function 2x squared negative 4x negative 1. We substitute the value of x as 3. Okay, it's 3 here also. And let us simplify this. It's 9, and that's 12, negative 1. That's gonna be, I guess, positive 5. Yeah, it's positive 5. So an additional point we've got as 3 comma 5. Let us plot that also. 3 comma 5 is located somewhere here. 1, 2, 3, 4, 5. So by symmetricity, we have its symmetrical point at the same distance in the opposite direction here. Now you notice it looks perfect, and just we need to here perform, we just need to connect them with a smooth curve. Yeah, that looks good. Should not be very sharp at any corner. It should be smooth, so we have to correct it. Yeah, it looks like a round object. Yeah, so that's how we can plot the given quadratic function which is in the standard form, and that's all about it. So there are certain things that we must memorize. If the leading coefficient, if it's positive, it opens upward. If it's negative, it opens downwards. The second thing is the axis of symmetry, which is x equals negative b over 2a. When we substitute this x into the given function, we get the corresponding value of y. That will be the vertex of the parabola. C is the y-intercept, and there are a few more points we may have to find out. So once we get them, we can easily plot the diagram. Alright, so that's all about it. Thank you.